Hey guys, I'm just going to go over a couple bonus balancing chemical equations. This video is for if you've been having a hard time with them and you need to see a couple more examples. I can also go over these with you when we have a chance to meet. So if I look at my first example, for some reason the arrows didn't print, so I got to draw them in. Arrow. Let's do this one first. So I have N and H, and I have N and H. So here I have two N's and two H's. And on my product side, I have 1 and 3. So let's start with our N's. Okay, so I have 2 over here and 1 over here. So I want to change the side that has less to equal the side that has more. So here I have 2 times 1 would equal 2. But that means I also have to change my H's. So 2 times 3 equals 6. Now my N's match, but my H's don't. So I need to think about what I need to put in front of my H to make it equal 6. So 3 times 2 is 6. Now here we have two reactants combining to make one product. So this is going to be a synthesis reaction. Okay? So let's look at this next one. Here we have one reactant breaking down into smaller pieces. So this is going to be decomposition. Okay, I'm going to draw my line. I have K, Cl, and O, K, Cl, and O. So I have 1 K, 1 Cl, and 3 O's. Over here I have 1 K, 1 Cl, and 2 O's. Now, this one is a little tricky because we have an odd and an even number on both sides. Everything's balanced except for the O's. Now, there is no number I can multiply by 2 to equal 3, and there's no whole number I can multiply by 3 to equal 2. So what we need to think about instead is what can we change these both to instead? What is a common multiple? So if I multiplied these together, I would get 6. So I'm going to make both sides equal to 6 instead. So first, I'm going to put 3 here because 3 times 2 is 6. And then I'm going to put 2 here because 2 times 3 is 6. Now when I put this 2 here, I also have to change these other guys. So I have 2 of each of those. Now because these are both 2, I need to change them over here too. So I'm going to put a 2 here, and it's going to make those both equal to 2. So now everything matches up. So sometimes if you get caught with an odd and an even number, you want to try and find a common multiple and change both sides to that multiple. Okay, so you might not be able to change one side to equal the other, but you can change them both to equal the same thing. Let's go over this one. Okay, so in this one, we have 2 compounds reacting to form 2 new compounds. And if we look closely, they're swapping partners. So if we have 2 compounds swapping partners, that's a double replacement reaction. Now here we can see our little polyatomic ion trick. If we see SO4 on both sides, we can keep it together as a group. So I have Al, Br, K, and then I'm going to keep SO4 together to make my life a little bit easier. Al, Br, K, and SO4. So Al has no number, so that means there's 1. Br has 3. K has 2, and then there's only 1 of this group. The 4 is part of the group, so we're not counting that. Al over here, there's 2, Br1, K1, and SO4, there's 3. So I'm going to start with my SO4. So here I have 3 on this side and 1 on this side, so I can multiply this one by 3 to make it equal. So now I have 3 of these, but that means I'm also changing my K's, so now those are going to be 6. So then if I jump over here, I can put a 6 in front of this to make my K's equal to 6 over here. But that's also going to change my BR's to 6. So remember, sometimes things might change around, but if you keep going, they're going to end up working out in the end. If they don't end up working out, my best tip is just start fresh. Sometimes with balancing, it's best to just start over instead of trying to work your way back to see what your mistake was. Because it's so many numbers and so many changes, you might have a hard time with it. Okay, so now, if I want my BRs to match, I put a 2 here. 2 times 3 is 6. 2 times 1 is 2. So now if I look carefully, these match, these match, these match, these match. They all match. Let's do 2 more examples. Let's do this one with you guys? Let's do this one. Okay, so here we have S and O on both sides. Now we have one thing breaking down into more than one piece, so this is decomposition. Make sure you guys can see for the most part. Okay, so this is a decomposition reaction. So in this reaction, oh wait, there's a little blur on here. Sorry guys. Hopefully that's not too bad. Okay. So we have one thing breaking down into more than one product. Now the reason I'm showing you this one is because the numbers get a little big, but I want to show you that it's okay and that can happen sometimes. So I'm going to start with my O's. So right here I have, actually no, let's start with S's. So I have 1 S and 8 S's. So I'm going to need to put an 8 over here to make it match. So now I have 8 S's here and I have 3, 6, 9, 12, 15, 18, 21, 24 O's over there. Now if I jump over here, my O's don't match. So I need to put a big number in front of this. 12 times 2 is 24. So we can get big numbers and that's okay as long as it's balanced. Let's do one more. Let's do this one up here. This is going to be our last one. Okay, so here we have a carbon fuel plus O2 makes CO2 and H2O. So this is one more combustion reaction. Okay, so now we have carbon, 3, H8, and O2. Over here we have C1, H2, and O3. Okay, so let's start with my carbons. So I'm going to put 3 here, so my carbons are now 3. And my oxygens now, remember, it doesn't multiply all of it. So I have 3 times 2 is 6, plus 1 is 7. Okay, now let's make my H's match. If I put a 4 here, 4 times 2 is 8. But it's also going to change this. So now I have 6 plus 4 is 10. Now this is a nice even number. So all I have to do is put a 5 here, and then I have 5 times 2 is 10. So that one worked out real nice. Okay, one more. Okay, here I have P1O2 and I have P2O5. So let's start with this part because it's going to be tricky. So like I said before, if I cannot make one side equal to the other, like here, there is no whole number I can multiply times 2 to equal 5, and there is no number I can multiply by 5 to equal 2. There's no whole number. So I need to think of a number I can change them both to. So instead, I'm going to make them both equal to 10. So on this side, I'm going to multiply by 5 to equal 10. And this side, I'm going to multiply by 2 to equal 10. Now when I do that, that's also going to change my p's to 4. Now all I got to do is come over here. 4 times 1 is 4. Here we have 2 things combining to make one product. So that would be a synthesis reaction. Okay guys, I hope these extra couple examples help you out. Please let me know if you have any questions or concerns, and have a great day.